Okay. Hello everyone. This is an CKY Parsing in the computer domain project. This project is all about understanding how computers can understand English question, especially those about computing topic. The main focus is on question we ask in computer science like what is machine learning? How do I install Python on Windows? Can you recommend me a book on Python? These are common questions people ask when they want to learn about programming, software, or computer science idea. To help computer understand this question, we use something called a context-free grammar or CFG. This grammar gives us a set of rules for how sentences are built. For example, can you recommend me a book on Python? This sentence has a clear structure that the grammar understands. We also use a special method called CKY Parsing. This helps us analyze the sentence step by step using table to show how it's built from the grammar rules. So here are a few of them. Can you recommend me a textbook on C language? What does ChatGPT do for you? Do I need a powerful GPU to train neural network? So finally, for each question, we will show a CKY table explaining how the sentence is parsed. In this part of project, we explore a few examples of questions that are not accepted by the grammar. These questions are either grammatically incorrect or structured in a way that the computer's grammar rule don't recognize. For example, one valid question is how I can learn machine learning. This question is not in right word order. It should be how can I learn machine learning. Another incorrect question is what was invented? The first computer. This also sound awkward because the subject and the verb are not the right place. So when was the first computer invented? Finally, we have what does means recursion. This as an extra word, which is incorrect. The proper question should be what does recursion means. This example show how important grammar rules are. The system we are using, the context-free grammar and the CKY parsing will reject this incorrect sentence. This helps ensure that only correct, clear, and meaningful computing related questions are accepted. Now let's go over the grammar used to generate valid question. This grammar is written in a structured way with rules that explain how sentences are built. Each rule shows the order in which the word or part of a speech must appear in the question. For example, one rule says a sentence can start with the word can, followed by a subject like you, then a verb like recommended, followed by pronoun like me, and a noun phrase like book, and finally a question mark. This rule generates a full sentence like can you recommend me a book? Other sentence rules include different patterns such as what is machine learning, which stand with what is followed by a noun phrase like machine learning. And the next is when was the first computer invented, which uses the past tense and place the subject after the verb just like in proper English. How do I install Python on Windows? So where the question starts with how followed by do I, then a verb like instant and ends with the object like Python and location on Windows. The grammar can also describe how parts of the Windows sentence are formed. For instance, a noun phrase can be something like Python or more complex like a powerful GPU or the Python language. We can also include preposition phrases like on Python or in computing and even full word phrase like to learn algorithms. The grammar defines the exact word that can be used to. It include common computing nouns like book, algorithms, network, recursion, as well as a proper noun like Python, Java, Linux, ChatGPT. It also lists common verbs such as explain, recommend, learn, install, means, and run. Helping words like do, can, is, and was are also defined clearly. Even small words like a, and the, and some are included so the grammar knows how to form a complete and correct phrases. Finally, we treat each word like I, you, and it as full parts of the sentence. These are considered noun phrases by themselves. This allow the system to correctly build question like, do I need a powerful GPU or can you explain recursion? Overall, the grammar is carefully built to um, reflect the English question in the computing world. It follows important English grammar rules such as the subject verb invention and correct word order and ensure that every person formed in both grammatically correct and meaningful in context. In the next step of the project, we ensure the grammar to show how these questions are broken down and parsed using a CKY table. So CNF grammar. Uh, in this part of project, In this part of project, we convert the grammar into something called CNF. This is a special format that is required for CNN parsing algorithm to work. In CNF, each grammar rule must follow a strict structure. Every rule must either have exactly two non-terminal symbols on the right side or one terminal symbol, which is just a word in quotes. This means we can't have long sentence or mixed type in a single rule, like three or four symbol or mixed of words and category. Everything has to be broken down into small symbols. To make this work, we introduce a new helper symbol like x0 and x0, x1, x2, x3, x4, x5, and so on that help split longer rules into smaller pieces. For example, the original rules S goes to can, then NP, then a verb like recommend, then a pronoun me, then another NP, and finally a question mark. It's too long for the CNF, so we break it down step by step. First, we say S goes to can and X0. Then X goes to NP and X1. X1 continues with the verb and next step bring it on pronouns, another noun phrase, and the question mark. One small step at a time. Each of these steps follows the CNN format only. Each of these steps follow the CNF format, only two parts at a time. This structure makes it easy for computer to build a past table, checking each piece slowly and correctly. We also renamed all the actual word in codes using labels like T underscore can for can, T does for does, and T what for what, and so on. This help us write clean CNF rules without mixing text and grammar tables labels. For instance, we write T can instead of just can, and when define T can equals can lexical rules. This CNN grammar still have same meaning as the original grammar. It also generates the same computing related questions, but it's now in a format that work with the CKY parsing. Each part of the sentence is now built step by step using a pair of symbol, and we remove unit rules and long sequence. Uh, at the bottom of this page, we also see a full list of non-terminal and terminal rules like determinants and the adjective likes powerful or neural nouns like GPU or recursion pronouns like Python and Linux and work like install, learn, and recommend. These are used to build blocks to form a complete question. In summary, the CNN version of this grammar make it possible to parse questions within CKY algorithm by following strict rules on the two non-terminals or one-terminal page rules and using helper symbols to connect everything in a structured way. So let's start with the transcript present sentence one. That is, can you recommend me a book on Python? Now let's walk through the CKY parsing process in the first sentence. Can you recommend me a book on Python? This is a valid computing domain question, and we will show how it get parse using the CNF form. We start by labeling each word into a sentence by its position. So word one can, word two you, word three recommend, and so on. So at very first label, which we call length one, each word is assigned to basic grammatical category. For example, can is recognized as an auxiliary verb and marked as T can. You is a noun phrase. Recommend is marked both as general verb and an det- detransitive one because it takes two objects like recommend me a book is a pronoun is determiner and book is a noun. On is a preposition and Python is a proper noun also considered a noun there. Normally the question mark is in tagged as Q mark. Next we begin combining pair of words to form larger parts of the sentence at length. Two, we find that a book forms a unit called NPO, a basic noun phrase made from determiner and a noun. On Python, forms a prepositional phrase because on is a preposition and Python is a noun that follows. At length three, we build a more complex noun phrase, a book on Python by combining two parts. We just built NPO, a book PP on Python. This gives us a full noun phrase that describes the object being recommended. Now we look at the core verb phrase, recommend me a book. First, recommend me is phrased using the rule for an intransitive verb followed by a pronoun. Then we add a book to complete the second object. At the point we successfully form a sum that means recommend me a book. We then contribute this on Python to complete the full action, recommend me a book. We then combine it to complete me a book on Python. This entire segment become a complete work phase. As we continue parse longer chunks of the word, we eventually combine everything to form U to Python. That's what to create into a simple structure representing a full request. Finally, we combine the first word can and the rest of the sentence using the rule as give t can followed by x0, where x0 represents the rest of the sentence, which also makes sure the sentence ends with the question mark. At this point, we build a complete structure from start to end, from word 1 to word 9. And we confirm that whole sentence is covered by the symbol S in the CKY table. This means the sentence is fully correctly parsed by our grammar. To summarize how this was from step by step, can comes from the symbol T. Can use a noun phrase. Recommend is a verb that takes two objects. Is and pronoun that indicate object. A book in Python is full form. Full noun phrase, the direct object. Question mark is in question marks. So the full structure becomes, can you recommend me a book? This successfully phrase confirms that our CKY parse and the CNF grammar correctly recognize and accept the question. Can you recommend me a book on Python? So the second sentence, again, the second sentence is, can you recommend me a textbook on C language? Let's go through how CKY parse analyze the sentence. Can you recommend me a textbook on C language? We begin by assigning grammar category to each word. Can is an auxiliary verb marked as T can. Use a noun phrase. Recommend is recognized as to transitive form that means it needs to object. So we begin by assigning grammar category to each word. Can is an auxiliary verb marked as T can. Use a noun phrase. Recommended it is recognized as to transitive verb. That means it need to object like someone and something. Is a pronoun. Is an determiner and textbook is a noun. Next on is an preposition. C and language are both nouns and Finally, we have question mark. At the smallest level, we group a textbook into a basic noun phrase that is formed by combining the determinant A and the noun textbook. Then we create a compound noun from C language by combining the two nouns. This is formed by combining the determinant A and the noun textbook. Then we create a compound noun from a C language by combining two nouns C and language. These are joined to form a more complete noun phrase. Then we add the preposition on. In front of that, we build the preposition phrase on C language. The next step is to build the main action of the sentence. Recommend in your textbook on C language. First, recommend me is created using this is transitive verb followed by an pronoun. Then we attach the noun phrase or textbook. Finally, the prepositional phrase on C language, creating the full phrase. Recommend me a textbook on C language. Next, we combine this full phrase with the subject you, forming the part you recommend me a textbook on C language. This become a complete clause. Finally, we add the word can using the rule T gives T and X. So this tells the parser that the full sentence starts with can and is followed by the rest of the sentence structure. After pending the question mark, we reach the final complete structure. So the full determination goes like this. C gives can. You recommend me a textbook on C language plus since the start symbol as covers the entire sentence from beginning to end. The CKY parser confirms that this is a valid sentence according to the grammar. Now the next sentence, can you suggest me some books to learn Java? As always, we begin by identifying each word that is can is marked as T. Can is noun phrase, suggest is an conjunctive word, meaning it take one object. Some is undetermined. Books is a noun. Two is the word that introduce an infinite word phrase. Learn is an verb. Java is a proper noun that is treated as a noun phrase here. Finally, we have an question mark. Next, we start by combining each pieces. Some books becomes a basic noun phrase created by joining determinant. Some with the noun books. Then to learn Java, it recognized as an infinitive verb phrase, starting with to followed by verb learn and learn Java. These two chunks, some books and to learn Java, are combined to form the full noun phrase, some books to learn Java. Now we construct the action. Suggest some book to learn Java. Suggest is an transitive word and it is followed by pronoun phrase. We just build. We create a valid verb phrase. When we attach the subject, you forming your suggestion book to learn Java. Finally, we attach the word can at the beginning to complete sentence using a rule. S gives T can followed by the rest of the sentence, adding the question mark to the end. So the final sentence is as gives can use suggestion book to learn Java. Since the full sentence is successfully built using a valid grammar rule, the start symbol has covered the entire span of forming the last word. The CKY parser confirms that the sentence is also valid. So the next is an invalid sentence. Now let's look at the three example sentences that are grammatically incorrect and see why our CKY parser and grammar cannot accept them. The first one is how I can learn machine learning. This sentence sounds a bit off to a native speaker and our grammar catches why. It has the wrong word order for an how person. The sentence starts with how followed by I can, but our grammar expect the word can to come right after how. Like in the correct sentence, how can I learn machine learning? Which we try to build this sentence using CKY parser. None of the rules matches the pattern. How I can. The correct structure should start with how with an auxiliary verb like can or do. and only in the subject like I. Even though learning machine learning could be a very poor phase on its own, it cannot be used here because the beginning of the sentence is already proven. The parser is unable to build any meaningful structure from the word how I can, and the result it fails to produce a complete sentence to uh, the top cell of the CKY table, which should contain the simple lines in sentence, so the sentence remain rejected. So next, let's come to the second phrase, second sentence. When was the invented the first computer? The sentence uses the passive voice incorrectly. The words are in the wrong order for the English passive language. The sentence began correctly with when was, but then goes directly to the word invented of what without extending with the what was invented. In English, we usually say what was the first computer invented. This is the first structure when the subject comes before the verb. Our grammar expect the form words plus noun plus past participle, but in sentence was is followed by directly by invented, which is break the rules. So this as a result, CKY parcel it's not able to build a complete sentence from the word given. It recognizes for smaller part like the word computer, but can't combine them properly with the word phrase. Once again, the start symbol has never appears in the final CKY table. So now let's come to evaluate sentence three. What does mean recursion? So the sentence has a problem with what the uh, word means in the third person singular form. But after the auxiliary verb does, English grammar requires the base form of the verb, which is mean. The correct sentence would be what does recursion means. In the in this incorrect version, the parser can recognize what does and recursion, but it cannot handle means because it does not matches the very verb rule after does. Our grammar has no rule that allowed us to be followed by means and means it's not listed as a very base word in grammar lexicon. Because of this, the word means does not get any category assigned in a parser table. As a result, nothing can be built on the top of the parsing table. So these are the three examples so that a grammar does not exactly what it's supposed to. It accepts only well-formed computing related question and rejects incorrect one. In each of these invalid cases, the CKY parser fails to build a complete structure because the sentence violates core English grammar rules, like incorrect word, order, or verb. That's why we say that sentence failed to parse. This proves that our grammar is not just accurate but also strict and reliable, filtering out the bad input incorrectly. To conclude, I can say that the provided CFG and its CNF equivalent successfully parse all the valid computing questions, as evident by the presence of the start symbol as in each of their CKY table. In contrast, the invalid question do not yield as demonstrating that the grammar rejects those ungrammatical structure is CKY table was filled in with, carefully justifying for each entry closely mimicking a step-by-step manual parser. This confirms the correctness and the restrictness of grammar for the intent domain of computing related questions. Thank you.